until now, our trig equations have centered here in the first quadrant. And all that we've needed to remember is to use the shift button on our calculator. So if sine alpha is equal to 0,4321, then we would say alpha equals, and we'd go shift sine, so arc sine, they call that, of 0,4321, and we get an answer there of 25,6 degrees. Okay, but what happens when we are not focusing just in the first quadrant? That is what this video is going to tell us all about. If we are asked to determine the general solution of something like this, so tan theta equals 1, you can use the shift tan button on a calculator. You get an answer of 45 degrees, but that just tells you an answer in the first quadrant. So let's take a moment to have a look at what is actually happening. How does the tan graph develop in all of the quadrants? So over here, I've just got tan between minus 360 and 360. Still not going to be the general solution, because the general solution would have no domain. It would apply to absolutely anywhere. But in this case, this is going to help us just come up with some conclusions here. Okay, so from our special angles, we know well that tan of 45 is equal to 1, plus once we've had a look at some graphs, we can see, okay, well, at 45 degrees, tan does equal to 1. Okay, so that's happening over there. But have a look again, a little bit further down on the Cartesian plane. There's another solution that is also true, and that's there between 180 and 270. So that's tan of 225 is also equal to 1. And in a similar fashion, on the negative side, we've also got more places where the tan graph is equal to 1. So there can be a solution. I can tell you that tan of minus 135, let's pop that in there, is also equal to 1, and I won't be wrong. Okay, and that's why we want a general solution. Because what a general solution does is it says this is true, and it's true every 180 degrees. Or if I move in the other direction, every minus 180 degrees. Okay, so when it comes to general solution, that's what I want to do. I want to find a solution, and then I want to apply this whole general solution pattern to say to people, you can actually go into any quadrant. If you add a certain number of degrees, you will end up with another solution. Now, if you remember back to your trig functions, a sine and a cos graph will have a period of 360 degrees. So we add 360 degrees however many times. K represents the amount of times we're going to add it. Okay, whereas a tan graph, like we've seen here, has a period of 180, so we'll add 180 degrees, however many amounts of times. Okay, so in this instance, to get to 225, I added 180 times 1 in the place of k. In this instance, to get to minus 135, I added 180 times by minus 1 in the place of k. Alright, so that's the concept behind a general solution. Let's have a look at a step-by-step way to solve these questions when they come at you. So here's an example. Determine the general solution of 4 sine theta equal to minus 0,4. Okay, the first thing we do is we isolate our trig ratio. Okay, so step 1, isolate the trig. In other words, the fact that there's this 4 here is a problem. So I'm going to take the 4 sine theta, and I'm going to divide both sides by that. So sine theta is equal to minus 0,1. The next thing I do is I apply the cast rule. So I ask myself, where is sine negative? Okay, and we can have a look here in our cast rule. Sine is negative either in quadrant 3 or quadrant 4. Okay, so that's going to be something that I'm going to keep in mind. Quadrant 3 and quadrant 4. That's where I'm going to apply my solution. Okay, now step 3, we want a reference angle. Okay, and NB about a reference angle is you ignore the sign. Okay, the sign we have already used, the plus or the minus here. Okay, the minus told us to go to quadrant 3 and 4 once we get our reference angle. So when I work this out, I'm literally going to type into my calculator shift sine, and then not minus, but just 0, 1. Okay, so reference angle, now we're going to go shift, sine, 0, 1, and we get an answer there of 5,74 degrees. Okay, small little angle. And now I can apply it in step 4. Apply to the quadrants. Okay, so in quadrant 3, okay, quadrant 3, theta, that's what we were working out there, is equal to, quadrant 3 is always written as 180 plus. So 180 plus my reference angle, plus, we're dealing with sine, so 360 degrees k. Okay, and we need to tell our teachers always that k is an element of the integers. In other words, I'm saying I'm never going to add half a period. I'm going to add the whole thing, and so I'm only going to use whole numbers here. Okay, and then we can work that out. Okay, let's apply it also then to quadrant 4. Quadrant 4. Quadrant 4 is the 360 minus quadrant. Ooh, theta equals 360 minus that reference angle of mine, plus 360k, and k is an element of the integers. Don't forget to say that. Okay, then what I do is I add my like terms, and I just get a nice neat answer. This is known as the general solution here. Okay, so that's a nice example. And then question 2 says, find theta if theta is an element between minus 360 and 360. So I'm now going to use my general solution to actually find an answer. Okay, so what I like to do is I like to just make a little list for myself. I start with k equals to 0. Okay, and I've got 2 solutions. So in other words, now I'm going to substitute a 0 in here, substitute a 0 in here. So I'm going to end up then with theta is equal to 185,74, and in the second solution there, theta is equal to 354,26 degrees. Okay, and both of those still fit within my domain there. Okay, they're not too big, they're not too small. Then I go on and I say, well, what happens if k equals 1? So now I'll substitute a 1, so it'll be 185,74 plus 360 times 1. Okay, and I can tell you now that's going to be too big for my domain. So I'm actually not even going to work that out. Okay, and this one here, definitely, if I add 360, it's going to be too big. So I'm not going to include that in my specific solution. Okay, let's substitute in a minus 1. So theta equals, that's going to be 185,74, and then times by, or plus 360 times minus 1. So that's the same as saying minus 360. Okay, that gives us an answer of minus 174,26. And that is still somewhere between minus 360 and 360. So that's cool. Okay, in this second solution, if I subtract 360 there, I am going to end up with a nice, neat answer. So 354,26 minus 360 gives me there minus 5,74, which is somewhere between minus 360 and 360. Okay, can I subtract a further 360 from each of these? I think I'm going to end up with answers that are too small, because that would be my next thing. Okay, the minute I see I can't, like 1 is too big, then it's pointless for us to go and substitute in 2 and 3, because they're all going to be too big. Okay, minus 1 is still working, so we could then try and say, well, what happens if k equals minus 2? What do we get? But I think in each case, we're going to end up with answers that are too big. Okay, so the specific solution then is these 4 values, and we need to list them from smallest to biggest. So theta equals minus 174,26 minus 5,74, 185,74, and 354,26. There we have our specific solution. Okay, let's determine the general solution of cos 2 theta minus 22 equals 0,222. So I want to isolate the trig ratio, but have a look here. This whole angle is all together. So technically the trig ratio is isolated, and I can jump straight into getting a reference angle. Okay, so we're going to go shift cos of 0,222, and we get an answer there of 77,17 degrees. Okay, now I'm ready to apply it. So according to my cast rule, I'm dealing here with a positive, oh sorry, let's put the positive there, positive 0,222. Okay, according to my cast rule, cos is positive in quadrant 1 and in quadrant 4. Okay, so in quadrant 1, I'm now going to use the whole angle. 2 theta minus 22 degrees is equal to, I take my reference angle and I add 360k. And k is an element of the integers. Okay, and in quadrant 4, I take that whole angle, 2 theta minus 22 is equal to 360 minus that reference angle plus 360k. All right, so let's go for it. We can now move these 22s over. So plus 22, and then we can collect all like terms. So let's add. Okay, and then to have an official general solution, I'm not solving for 2 theta, I'm solving for theta. So I now need to divide everything by 2. So there is the general solution of that. So be very careful when isolating your trig ratio. Make sure that you don't split up an angle that's supposed to be kept together. Okay, so you jump straight into reference angle, and once you've allocated the quadrants, then you start to isolate and just solve for theta there. Here's one that comes up often at grade 11 level. So determine the general solution of 3 sine theta plus 2 cos theta equals to 0. Okay, so what I need to do is isolate my trig ratio, but the problem is I've got more than one. Okay, and this is where my knowledge of the trig, the fundamental identities of trig is going to be helpful. Okay, so let's start and just get one on each side. So if we move this 2 cos across, we'll have 3 sine theta is equal to minus 2 cos theta. Okay, and now what happens? This is the only time I'm allowed to just divide by something, and that's if I divide by cos theta, so that I can get rid of a cos and turn a sine over cos into tan. Okay, we don't want to just throw away solutions, so always be very nervous to just divide, but in this case we are allowed. So this then becomes 3 tan theta equals minus 2, because cos and cos, those are going to cancel. And now let's divide both sides by 3, and so we end up with the fact that tan theta is equal to minus 2 over 3. And now we've got to do general solution things here with the tan ratio. Okay, so I want to get a reference angle. Let's do that over here. Reference angle. Remember to ignore the sign, hey? So shift tan of 2 over 3. And then we get an answer there of 33,69 degrees. And now we use this negative to tell us which quadrants we want to work in. So where is tan negative? Quadrant 2 and quadrant 4. Okay, now remember that the period of a tan graph is actually just 180 degrees. So in this instance, if you were to work out quadrant 2 and quadrant 4, you'll get exactly the same answer. And so when it comes to tan, you actually don't even have to do that. You can just say, I'm going to focus here, because you will end up with exactly the same answer, because you are adding 180k to your general solution. So now we can say, okay, general solution here, theta is equal to, in quadrant 2, 180 degrees minus this reference angle, plus 180k, because it's a tan ratio, and k is an element of the integers. Okay, so let's get that reference angle. Okay, let's get that solution. So theta is equal to 146,31 degrees plus 180k. And you can check me, if you work this one out, would you end up actually with this exact same answer, but adding 180? So in other words, would you end up with 326? Let's write it down there. 326,31 degrees, and you certainly would. And so that's why when we end up with a tan, we don't need to do both of those quadrants. Okay, so be careful there and save yourself some time.